hope you had a good time yesterday, and I hope you'll have a good time today as well. Let's just jump straight in. Our first speaker for the day is Adam Hawkins. He's from Bangalore and handles site reliability engineering for SaltSide. And his talk is about stability, operability, and debuggability of production Ruby apps. So over to you.
Thank you. So, good morning, everybody. I hope you're adequately awake for this, because we're talking about something that is, I think, very important to all of our work. So, my first thing I'd like to do is just thank the organizers for preparing this conference. It's been very nice, so applause for all of them. And also a round of applause for our lovely Mats for giving us Ruby itself, the reason why we're all here. And I pray to the production presentation gods that I don't have the same issues that, that you did, Mats. So my question for all of you is, how many of you are part of an ongoing on-call rotation? Please raise your hand. So that's what? 2 people? 2 or 3 people. Okay. So then raise your hand if you don't operate your code in production. So that so then that sort of begs a question for me. Then what do you all do once you deploy your code to production? Are you involved with it? Is it just sort of run by somebody else? Or maybe let me back up a bit then. Is how many of you are actually building code that goes to production right now? So then how come none of you raised your hands for the other questions? Where do we fall in this spectrum, right? So this is why I think this talk is important for all of the people who did not raise their hands to the first question, is how many of you are involved with the production operations of your code? And the reason why this is so important is because I think our job as engineers is to own the code from the moment we commit it to all the way through to running in production. And if you're not involved with the production operations of your system, then you're really not doing very good work. I'm sorry if that hurts your feelings, but you need to be involved all the way through to learn about how the decisions you make as a developer impact the production operability and production stability of your whole application. So my goal with this talk is to prepare you from a kind of mental model of what you need in your production application. So when I talk about production-ready code, what I really mean is addressing 2 different factors, okay? The first factor is your code must be structured in a way to reduce the mean time between failure. So what this really refers to is engineering practices that remove regressions, okay? So when we deploy code to any environment, that code should always be free of all known regressions. So that's bugs, all sorts of different types of things. So the second thing is that your code and your kind of infrastructure needs to be designed in a way that you have the capacity to reduce your mean time to resolve. So we're talking about this from 2 ends of the spectrum, okay? One end is reducing the number of defects that are shipped to a production environment, and the other end is being able to quickly resolve the issues that do appear in production. And regardless of how many known regressions you find, there will always be unknown regressions that appear in production. So the first thing we can do is we can reduce the number of bugs by changing or using specific engineering practices, and we can increase the mean time to resolve by adding appropriate telemetry. So what are these practices that I'm talking about? First one should be hopefully obvious to many of you, which is no new code without tests. How many of you are writing or working on an application with a test suite? Please raise your hand. Okay, good. How many of you are fixing bugs with regression tests? Raise your hand. So this is the first thing that you can start doing to improve your mean time between failure. I will argue that if you have found a bug and you have not added a test to your test suite, you have not actually solved that bug. Because I guarantee you it will come up again in a future change. Because you have nothing to guarantee that that regression no longer appears. So if you're not doing that, that's something you can start doing today. So that's regression tests for application layer bugs. This is probably the entry point for a lot of you. But the next thing that happens is once you kind of clear out all of the application layer bugs, you get into another class of failures, which is kind of the misconfiguration or general errors with the processes that you're going to deploy. So let's say that you have a web server. How many of you actually boot your web server before you deploy it to production in a test environment? Great. So unfortunately, nobody has raised their hand. But this gives you an opportunity to catch a certain class of failures, and we're going to cover that as we go forward. So how many of you write utilities that are involved with, say, the production operation of your system? This is things like, okay, maybe I need to massage some data or do something else, right? If we talk about Rails applications, this is stuff like things you would put in your rake tasks or whatever. So how many of you are writing custom code designed to operate in a production environment for like this utility type thing? Raise your hand. Okay, that's most of you. How many of you are testing that code? Okay, a few people, right? How many people actually invoke the same command that you would use in production before you use it in production? Okay, a few people. So this is the first place to start, in my opinion. This is some practice that I started doing with me and my team that eliminated a whole host of different kinds of regressions we found as our application moved through the different stages of the software development process, from the development, testing, all the way up to staging into production. So first thing is, the first place to start for me was taking a step back from my application, right? We're Ruby programmers. We write our applications in Ruby, but we don't actually start our applications with Ruby. We start our applications via the command line. That's the entry point we have as engineers. So if you're supposed to start your server with bundle exec rack up, you should run that command to make sure it does work. Then you can pass it off to some sort of smoke testing thing. How many of you run your application behind a load balancer? Okay, that means you'll have some sort of health check request for the load balancer to know that this process can receive traffic. How many of you test that request before going to production? Okay, maybe one person raised their hand. But this is a type of regression that can completely crash your application in production. That if you deploy it and your load balancer expects to hit, say, path/ping, but you've broken that request for some reason or mistakenly changed the path or anything like that, then that application will not function in production. These are very simple types of things that you can just test. So in this case, we have a BATS smoke test. What this does is just runs a curl to any sort of important paths in your application, which is, okay, maybe you have your health check, which is probably the minimum thing that needs to be hit. You don't necessarily need to test any kind of outcomes, just that, I need to have a request that is my health check, I should get 200 back from it. And you can do a curl, right? So what this does is test, one, that the server did in fact start, which is very important. And number two, that the requests advertised by the server are accessible by any networking client, like curl or anything like that. How many of you use rack test or something like that in your test suite right now? Or capybara, anything like that? It's most people, right? That doesn't actually, in most cases, that doesn't actually start a server. That's just calling Ruby APIs to simulate requests. But you can have all types of failures that come at the networking layer. Maybe you're not using the same middleware you have in test as you would in another environment, which can create problems. So the idea here is just to quickly smoke test some of this most important, fundamental, operable aspects of all of your processes, right? It's not just web servers or anything like that. Let's talk about processes, because we're all shipping processes. And you should also just invoke these important utilities that you're going to need to use, right? So if we're talking about a Rails application or any sort of web application, you'll have some command to probably prepare a database or migrate your database. Maybe you run that as part of your test suite, maybe you don't. Maybe you run like rake-db schema load, but you don't necessarily run the migrations. But there can be code in your migrations that is never invoked until you get to a production environment. So for all of these sort of utilities that you have, you should at least invoke them the same way that you would invoke them as an end user of the system, right? In this case, just an example, bundle exec util reset. So by doing this kind of practice, we can eliminate a whole host of regressions that's not typically caught by most engineering teams' processes. So I mentioned again that once we started doing regression tests, removing all the application layer bugs, then we found sort of these kind of like operability or infrastructure-related things that are not necessarily required in the test suite, but have an impact in other stages of the software development pipeline, right? And if you're following the practice of no new code or no bug fixes without tests, if you find a bug in, say, some configuration or something like, the health check request we use for the load balancer is not executed in the test suite, then you need to add a test for that. So you can take that same mentality and apply it to all the different phases of the execution of the process. So next step, that was talking about things that we can do to reduce the amount of regressions before going to production. Now we tackle the other side of this, which is being able to quickly resolve issues that do appear in production. How many of you have heard the term telemetry before? Please raise your hand. Okay, so for me, telemetry is the data required to understand the current state of an application. Okay? If you can understand the current state, you can also save that data to correlate it to a past state. For example, we deployed something now. The latency of this request is X. What was it before? Have we improved something or have we created a problem? Without having the appropriate telemetry, you won't be able to answer those questions and thus act on issues that occur in a production setting. Also, I encourage you not to make the mistake of thinking that telemetry is only about technical data, okay? So consider a site like Amazon. They're e-commerce. They're processing orders. What matters to them is the number of incoming orders, the number of fulfilled orders, right? The number of money that's passing, the amount of money that's passing through their system. That's ultimately why Amazon exists. They don't exist because they think that the latency of this API call to process an order should be less than, say, 100 ms. What they care about is the amount of orders or whatever sort of business data that is important to them. So when we talk about telemetry, you have to correlate or you have to include business data and technical metrics. So the whole point of this telemetry is to be able to answer basic questions about the current state of your application. So if we take a simple web server or any kind of server, if you were in the unconference thing, you heard me talk about thrift servers or different sort of RPC servers. These are all processes that accept incoming requests, do something, and return some response to some client, right? So what you need to be able to answer is, how is my server doing? And it's kind of straightforward. You need to have a counter on every single request, so every time it comes in, increment a counter. You need to have a counter on the result of every request to know what is happening, how is my server responding, and you also want to know the latency. So here we have example counters and gauges for the different types of things. These are just kind of proposed like statsd or metric key names. So HTTP response at 2xx, 3xx, 4xx, 5xx. Between those metrics, you can get a very good overview of, is the server okay? Is it failing, or is it on fire? Now, the same thing kind of applies to dependency telemetry. All of our applications usually depend on one or more other things. This might be a database, this might be a cache, this might be any number of APIs, this might be any number of internal services. But the same principles apply. The overall telemetry of our application is kind of the sum of all of the telemetries of its dependencies. So in the same way, we need to know how often our applications are making requests to external dependencies, right? A counter on the response or the result of every request. So are these requests succeeding? Are they failing? And also the latency of every request. So let's say that you're processing incoming orders, Amazon again, and you see that this one is taking, say, 1 second. But if you don't know what service or what part of your application is taking up most of that 1 second, you won't be able to actually diagnose and then resolve that problem. You can't resolve any issue until you diagnose it. This is what telemetry is for. Telemetry cannot resolve things for you. That's your job. It gives you the information you need to make an informed decision as an engineer to ultimately resolve an issue. So we also have queues. So when we talk about queues, you need to be able to answer the question, are things moving through my queue? Rate is one thing, but ultimately you need to know that the queue is being processed or not. So in this case, you need to know about jobs coming in, basically the input and output of each of these things, and at least a counter incremented on, say, the outcome again. So failed or succeeded. If you see a spike in the failed jobs, you might see a spike in requeues. You can correlate those things. You can have an alert, say, on the number of items in a particular queue or not. So like all of these different telemetries, you need to be able to aggregate them across each different queue in an application. So this could be, say, your email queue or some sort of like background job queue or any way you want to call it, but you need to be able to aggregate those things across all the different like slices in your application. How many of you are using thread pools or connection pools in your application right now? Okay, so only a few people raised their hand, which probably means that most of you are unaware that most of the drivers or the connection things for, say, your database or whatever actually are using a connection pool under the covers. And that connection pool can be a huge bottleneck in your application. So let's take a threaded server, a threaded process. Let's say that you're running Puma. How many of you are using Puma right now? Okay. How many of you are using it in threaded mode? Okay, a few people. So if you have, say, a threaded process, your main process is going to have, say, n number of threads. But if your thread pools have less than n, you're going to have contention potentially between the thread serving the requests and the thread's capacity to reach its dependencies. So what you need to know is the load on the pool. So a counter incremented on check-in and decremented, or yeah. So you can see in and out. And also you want to know how long a particular thread waited to get an item from that pool. That way you can answer the question of, my requests are blocking because the load on my thread pool is too high, so I cannot read from this database. Or make a call to some other external service. So I have to speed up a little bit. Interacting with telemetry. So now that you have this data, what should you do with it? right? So my advice to you is give everything a name. So your requests should be something like, you want to maybe have a counter on incoming orders compared to looking things in like technical terms. That way you can see, the request for, say, update user profiles in relation to something else. When we talk about latencies, you want to look at your P50, which is your median, your P90, and your 95th percentile. So your P50 will give you sort of the normal case, but your P95 will give you the real-world case. And your P95 hopefully will be close to the lower ones, but it might be even higher. So if you want to look at your real-world performance, look at your P90 or P95. When it comes to the other things like the outcomes or the latencies, you want to be able to look at those in a histogram or a heat map. That way you can easily see, okay, 80% of my requests are succeeding, 20% are failing. You can automatically tell from that, based off of your knowledge of a system, what is the expected state of these things. So for, say, customer or whoever files a report saying something is broken, you can say, yes, 30% of these requests are failing. That's probably not correct. So also remember, you'll always need to sum or aggregate these things across all of the different subsections of your system. Like I mentioned, queues. So talk about HTTP requests. You'll probably also want to aggregate that across, say, maybe the path names in your application. Like, for example, the GET requests are taking longer than the POST requests or something like that. But you need to make sure that you have the metadata associated with each of these telemetry points to do that kind of filtering. And just standardize whatever practice you have across all of the different applications in your wider system. So it makes it easier to compare and work with these things in your analysis tools. And always, always be sure to be able to correlate technical metrics with business metrics, like the number of incoming orders, say, compared to the latency of the time to process an order. That way, when somebody says, we're not able to, say, place orders, you can say, it looks like things are timing out because they're taking too long. All right, I got 3 minutes to talk about logging. This sort of TLDR here is that you only need one logger object for your whole system, log to standard out or standard error, and use the Ruby standard library logger. You literally need nothing else. If you output to standard out, it makes it easy for other tools to, say, redirect those logs to a file, redirect those logs to some aggregation thing or whatever. And you don't really need any fancy logging libraries. The standard library is really more than enough than you need. So here's an example. How many of you actually know about prog name in the logger library? Okay, a few people. But this is just in the standard library. It's a hidden gem. What you do here, in this odd-looking form, your first argument is a prog name, and then your message. Then you can see here, the default formatter will automatically add the prog name. So that makes it very easy to filter out your logs between things like, this was the actual HTTP server, this was my queue, this was this thing. It's just there. So here's an example of how you can create a delegate class to just decorate these loggers with these particular prog names. Okay. If you haven't heard of the delegate library, I suggest you check it out. Also part of the standard library, very, very useful. Here's an example. Instantiate your logger, create some name loggers, and then pass those off to the various bits or objects in your system that need logger objects. Then when you watch your logs, you'll see these are your servers, these are your queues, this is whatever aspect, however you want to filter them. So we've reached the end, and my recommendations for you are to increase, or actually they're out of order, but decrease your mean time, increase your mean time between failure by using proper workflows. That's taking the steps necessary to reduce bugs and reduce regressions before they enter a production environment, right? Decrease your mean time to resolve, aka resolve issues more quickly, by having the insight via telemetry you need to properly diagnose failures, right? Smoke test your processes and production utilities. If you take nothing away from this talk, just do this. This will eliminate a whole host of regressions. I suggest you use StatsD for this metric data because it's very simple. You just push data out. It's very easy to integrate it with any type of system. Use the standard library logger and use a log level environment variable. If you encounter a scenario where something is going wrong and you need more data, you should be able to get more data without having to deploy code. And we can do that by changing environment variables. So if you're using, say, log level error or warn in production, something goes wrong, you should be able to say, OK, change log level to debug and start the process again. Or if you want to get super fancy, you can implement a signal handler for your process where you can send your process a signal and then bump the log level without having to restart the process. Okay? Use a remote collection, like a remote exception collection service like Bugsnag or Airbrake. Standardize your telemetry practice across all of your applications and teams. Also, follow the documented telemetry best practices for your database or data stores. Things like Mongo and RDMS have their own documented, well-known metrics you need to look at. Make sure you have those in place. And also design your application for failure. This is such a wide topic. But when we talk about production systems, things are going to go wrong. And say, if you're dependent on an upstream service, what are you going to do if that service goes down? How are you going to perform if that service is degraded? This is a big topic, which is why I suggest you read this book, Release It. It's a fantastic, fantastic book. It's actually quite old now, but all of the practices and patterns in that book apply to any type of thing you'll be deploying today. So if you don't have any existing experience building or designing for production, then I highly, highly recommend that you read this book. It's like a 200-page book. It's not very long, but it's jam-packed with fantastic information, especially for sort of newcomers to this area. So that's all I have. There's some links here. I'll post these slides online later today. And feel free to find me in the hallway and ask me questions. I am more than happy to discuss this stuff all day until my tongue falls out. So thank you, everybody.